Problem number 9. On problem number 9, we have a natural log on the left and on the right. I'm going to go ahead and get rid of the log on the left. The opposite of a log will be a base. In this case, will be base E on the left and on the right. The ln and the base E cancel each other out. X plus 5 is equal to, on the right, cancels out as well, 3x minus 5. And now I just solve the equation. Move my 3x to the left, becomes a negative 3x. Move my 5 to the right, becomes a negative 5. We have a negative 2x is equal to negative 10. And divide by negative 2, divide by negative 2. That cancels. X is equal to positive 5. Remember that whenever you are solving an equation, you want to make sure that whenever you plug in the 5, you answer. Whenever you're solving a log equation, you want to make sure that you answer when you plug it in gives you a positive number. It cannot be 0. It cannot be negative. So 5 plus 5 will be 10. So that's fine. If you plug it in here, 3 times 5 is 15. Minus 5 will be 10. It's perfect. Now let's continue to problem number 10. These are the ones that sometimes you guys have a challenge with. But it's very similar process. I have an 81 on the left. On the right I have a base of 3 and the exponent is the 5x minus 6. I want to get rid of this base. So the opposite of base will be a log base 3 on the left, log base 3 on the right. That cancels out. On the right hand side I have a 5x minus 6. On the left you can think about it two ways. 3 to what exponent will give you 81? Or you can rewrite it as log base 3. The 81 is 3 to the power of 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th power. That cancels out. I have a 4 left. So 3 to the power of 4 is 81. Move my negative 6 to the left. You can say positive 6. That's a 10 is equal to 5x. Then divide by 5 on both sides. That will cancel out. X is equal to positive 2. Problem number 11. On problem number 11 it says solve for x. And be sure to check for extraneous solutions. So you make sure that you check and show me the check on the left hand side or on the right. I'm going to draw the line. I have two logs on the left hand side. I have log base 2 of x plus the log base 2 of x minus 3. First thing, I'm going to combine both logs into one. So I'm going to have log base 2, I'll place a bracket, is equal to 2. Now, because there's a plus, that means that I'm going to be multiplying the x and the x minus 3. X multiplied by x minus 3. Now I can get rid of the log. Opposite of a log will be a base. I'm going to place a big base on the left and the right. That will cancel my log. I'm going to use my distributive property. It gives me x squared minus 3x is equal to 2 to the second, which is 2 times 2 is 4. I'll move everything to the left. Since I see a quadratic equation, I'm going to move everything to the left and make it equal to 0. That gives me x squared minus 3x minus 4 equal to 0. Now I'm going to try to factor it. If I cannot factor it, I'm going to try using the completing the square. But because this is not even, this is odd, I cannot complete the square. Therefore, if I can factor it, I'm going to have to use the quadratic formula. But in this case, it factors nicely. We have an x and an x. Factors of 4 will be 2 and 2 or 4 and 1. I'm going to use my 4 and my 1, negative and positive. I'm going to use my zero product property. Since they are multiplying, and it's equal to 0, I'm going to use my zero product property. That means that 1 or both have to be equal to 0. X is equal to 4, x is equal to negative 1. Now remember that we need to check. I'm going to plug in a 4 in here. This one's fine. And in here. So let's check. Check. X is equal to 4. So instead of x, I'm going to place parentheses. That is 4. Is that bigger than 0? Yes. Instead of the x, I'm going to place a 4. So it'll be x minus 3, but instead of the x will be a 4. Is that bigger than 0? Yeah, that gives me 1, which is bigger than 0, so this one's fine. I'm going to plug in a negative 1. So I'm going to check x equal to negative 1. I can't plug it in here because that gives me a negative 1, and you cannot take the log of a negative number. So therefore, you want an answer is x equal to 4. Let's continue to the backside problem number 12. On problem number 4, it says, if the equation y is equal to 2 to the power of x is graphed, which of the following values of x will produce a point closest to the x-axis? Now, first, you need to determine if this is an exponential growth or an exponential decay. This is bigger than 1, therefore it's going to be a growth. If you cannot remember if it's a growth or not, you can just plug in let x equal to 0. Plug in different values for x. 2 to the power of 0. 2 to the power of 0 is 1. Anything to the 0 power is 1. So if x is 0, y value is 1. Plug in 1. Let x equal to 1. 2 to the power of 1 is equal to 2. If x is 1, your y value is 2. If x is 1, y value is 1, 2. Then let x equal to 2. 2 times delta x will be a 2. Is equal to 2 to the second power will be 4. Therefore, if x is 2, your corresponding y value will be 4. Yeah. 1, 2, 3, 4. Notice that this is an exponential growth. If you already know that's an exponential growth, you don't have to do this, it's fine. The question is asking you which of the following will produce a point closest to the x-axis. So if you plug in a 0, you get this point. Plug in a 1, you get this point. Plug in a 2, you get this point. Plug in a 3, you get this point. Actually, much higher. Plug in a negative 1, get this point. Plug in a negative 2. So we're looking for the smallest number. The smallest number will produce a point closest to the x-axis. As you go further to the left, it gets closer and closer. So you just need to determine which is the smallest number. I know that 1/2 is 0.5. 3/7. You do long division. 3 divided by 7. 7 goes into 3. None. 7 goes into 30. 4 times. 4 times 7 is 28. So, looking for the smallest number. 7 divided by 8 is almost 1, so that's not it. 5 divided by 8. 8 goes into 5 0 times. 8 goes into 50 6 times. So the smallest number will be 0.4, which is 3/7. So remember that you first need to determine if it's an exponential growth or decay. Once you sketch it, then you can analyze the graph and say, okay, which of those is the smallest number or the biggest number producing a point closest to the x-axis? In this case, will be the smallest number.